Probability distribution with algebra formula. The number of sales that a telemarketing salesperson makes in an hour is a random variable x having the following probability distribution. P of x equals lowercase x equals x plus 2 times 5 minus x over 50, where x equals 0, 1, 2, 3, or 4. Construct a probability distribution of x, then draw probability histogram. A probability distribution of x lists the value of the random variable x with the corresponding probability. The possible value of x in this case are 0, 1, 2, 3, and 4. These are given. We now find the corresponding probabilities, but we are given the probability distribution already, and so we just simply plugged in x. When x equals 0, we replace x with 0 in the formula to get 0 plus 2 times 5 minus 0 over 50. Notice that we write everything the same except that everywhere we see an x, we replace it with the value of x. In this case, when x equals 0. 0 plus 2 is 2, 5 minus 0 is 5. We multiply the 2 divided by 50. This is 10 over 50, which is 0.2. And so we have 0.2 when x equals 0. When x equals 1, we have p of x equals 1 equals 1 plus 2 times 5 minus 1 over 50. And this is 3 times 4 over 50, or 12 over 50. But 12 over 50 is 0.24. And so when p of x equals 1, we have 0.24. And we do this for every single value of x. P of x equals 2 equals 2 plus 2 times 5 minus 2 over 50. And this is 4 times 3 over 50, which is 12 over 50. And we see that this is 0.24. When x equals 3, we have p of x equals 3 equals 3 because we replace x with 3. 3 plus 2 times 5 minus 3 over 50. And this is 5 times 2 over 50, which is 10 over 50, or 0.2. 0.2 when x equals 3. And lastly, p of x equals 4 equals 4 plus 2 times 5 minus 4 over 50. And this is 6 times 1 over 50. And 6 times 1 over 60 is 6 over 50, or 0.12. And so we found all of the corresponding probability for each of the value of the x. We can also double check that each of these values is between 0 and 1. And if we take 0.2 plus 0.24 plus 0.24 plus 0.2 plus 0.12, we would get exactly 1. Next, draw a probability histogram. The probability histogram lists the value of x in the horizontal axis with the corresponding probability in the vertical axis. And so in this case, we list the number 0, 1, 2, 3, 4. Now, the histogram consists of bars or rectangles, and they have to have the same width. For the probability histogram, the size of the width of each of the rectangle needs to be 1. And the height of the rectangle is the corresponding probability. The highest probability in this case is 0.24, and so we will use the scale 0.12, 0.24. 0.2 is a little bit below 0.24. And so for the first rectangle, when x equals 0, the probability is 0.2. And so we only go up to 0.2 and we draw a rectangle with the width of 1 and the height of 0.2. For the second rectangle, when x equals 1, the height or the probability this time is 0.24. And again, the width is 1. So they should have the same width here, 0.24. For the value of x equal 2, the probability is also 0.24. So we would draw another rectangle with the same height, 0.24. For x equal 3, the height is now 0.2, same as when x equals 0. Again, the width of the rectangle is 1. And lastly, when x equals 4, the height is 0.12. And so we only go up to 0.12. This is known as the probability histogram. It looks like an ordinary histogram, but again, the width of each of the rectangle is 1, and the height of the rectangle is the corresponding probability for the random variable value x.